Alright, so we've had a look at two different types of depreciation, and here's our lucky last one. So we've had flat rate, where it went down by the same amount every time. We had reducing or diminishing rate, where it was always a fixed percent of the previous balance, the previous value. Okay? And then finally we've got unit cost depreciation, where it's not necessarily coordinated with the number of years. So what unit cost depreciation is, it's when the product depreciates with each use of the item. So this might be each kilometer you drive, or each copy that the photocopier spits out, each minute that you use on your phone. Okay, so there's a few implications to this. First of all, it implies that with each use, some of the value is lost. Okay, what kind of comes from that is that there are a fixed number of uses before it reaches the scrap value. Okay, so for a car, it might be after 250,000 kilometers, at that point it reaches its scrap value. Okay, so that means that each kilometer you drive, you're taking off a teeny tiny portion of the car's value. Okay. So let's first look at this in terms of a recurrence relation, and then we'll have a look at it in terms of the general formula. So recursively, same kind of concept as flat rate, but it's the meaning of D is changed a little bit. So to get to the next balance, so to get the current from the previous, I subtract off D. Again, in this case, D is still depreciation, but it's not the yearly depreciation. It's the depreciation per use. Okay. Now this use may not just be driving a single kilometer. It could be driving 100 kilometers or 1,000 kilometers. So it's per unit of use. Okay, so that means the meaning of VN is the value, again, after N uses, where a single use can look different. So it might be a single sheet of paper or a ream of paper. Depends on how it's defined in the question. So let's look at an example. So we purchase a car for $21,000. Okay, so that's its V0, its initial value, and it loses $120 per 1,000 kilometers. So for every 1,000 kilometers you drive, it loses $120. So you could also think about that as for every 100 kilometers you drive, you lose $12. For every 10 kilometers you drive, you lose $1.20. For each kilometer you drive, you lose 12 cents. Okay, so, but I'm considering I don't want to be having to go to a next value in the table after every single kilometer, because then you're going to have 250,000 rows in your table. So I'm going to put it in groups of driving 1,000 kilometers. So now my use is driving 1,000 kilometers. So I'd like to set up a recurrence relation for this one, because again, I'm told exactly how much I lose each time. We don't have too much to go through here. Okay, so what I end up with, well, it's going to be Vn, my current value, is whatever the previous value was minus 120. Okay, again, my V0, always important to state, is equal to $21,000. So now I'd like to set up a little recursion by looking at the depreciation schedule. Okay, so in addition to stating what N is, I've also kind of put the distance to help us remember that N is not the distance driven, it's the number of uses, where each use is driving 1,000 kilometers. Okay, so I want to go up to 5,000. So initially, I haven't even driven off the lot yet. My car is still worth $21,000. Drive off the lot, do a little bit of driving. To get to the next value, I subtract 120. Okay, so that's going to give me $20,880. I then drive another 1,000 kilometers, so subtract another $120. So I get 20,760. And I keep going, subtract off another 120, 20,640, 20,520, finally 20,400. So every single time I go, when I drive 1,000 kilometers, I take off $120. So that's the idea with recursion. Big thing to remember is that a use is not necessarily a single kilometer, it could be a block of uses. Okay? So that's the basic theory and how to use it recursively.